Ever wondered how modern apps, the ones you use every day, run at such a massive scale? Well, you're in the right place. Today, we're going to break down three of the most fundamental concepts in Kubernetes: pods, services, and ingress that take your code and turn it into a powerhouse cloud-native application. Let's dive in.
Okay, so you've built this awesome app. It runs perfectly on your laptop. But now what? How do you actually get it out into the world, make sure it's always online, and can handle, thousands of users at once? This right here is the exact problem Kubernetes was designed to solve, and we're going to build up the solution one piece at a time.
So before Kubernetes can work its magic, we need to give it our app in a format it understands. And that format is a container. So the very first thing we have to do is take our code and package it up into a neat, portable, self-contained little box. It really just boils down to three simple steps. First, obviously, we've got our application code. Second, we write a kind of blueprint called a Docker file, which is just a set of instructions on how to package it all up. And third, we run one command to actually build that package, and what we get is called a container image. For this walkthrough, we're keeping things really, really simple. We're using a basic Node.js web server. All it does is say hello. That's it. The point here isn't the app's complexity, it's all about how we get this app running and make it scalable. Think of the Docker file as a recipe. It lists all the ingredients, our code, the libraries it needs, the runtime environment, and then provides step-by-step instructions. With a single command, docker build, this recipe creates a perfectly packaged, ready-to-run container image. All right, we've got our container image locked and loaded. Now we're ready for the fun part: Kubernetes. Let's get into our first core concept and see how we actually get this thing running inside what we call a cluster. So meet the pod. A pod is the absolute smallest, most basic thing you can create in Kubernetes. You can kind of think of it like a tiny little apartment that holds our container. It gives our app a place to live, its own IP address, and a network. But, and this is a big but, pods are designed to be temporary. They can crash or get deleted at any moment. And that brings us to a really important question. If these pods can just vanish into thin air, how on earth do you build a reliable app? You can't have your entire application go down just because one little pod had a bad day. We need someone in charge. We need a manager. And that manager is called a deployment. Think of the deployment as a supervisor whose only job is to make sure you always have the right number of pods running. We call these replicas. If a pod dies, the deployment sees it happen and instantly spins up a new one to replace it. This is the magic behind Kubernetes' self-healing powers. Now, how do we tell the deployment what to do? We use a simple configuration file. We just declare what we want. In this case, we're saying, hey, I want 2 replicas of my app running at all times. We also point it to the container image we built earlier, and that little image pull policy never is a neat trick for development. It tells Kubernetes to use the image from our local machine instead of trying to find it online. So after we apply that file, we can ask Kubernetes what's going on. We run a quick command, and bam, exactly what we asked for. 2 pods, both up and running. Our application is officially live inside the Kubernetes cluster. But there's a problem. Nobody can actually get to it yet. Okay, so our pods are running, which is great, but they each have their own private temporary IP address. We need a stable, reliable way for other parts of our system or even the outside world to talk to them. So let's look at the next building block. This is the next puzzle we have to solve. If you connect directly to a pod's IP, what happens when that pod crashes and the deployment replaces it? The new pod will have a brand new IP address, and your connection is broken. We need something like a permanent address. And that's exactly what a Kubernetes service is for. It acts like a stable front door for a group of pods. It gives them a single, unchanging IP address and a DNS name. When you send a request to the service, it intelligently forwards it to one of the healthy pods behind it. It's like a building's mailing address. It never changes, and it always knows which apartment to deliver the mail to, even if the residents move around. Now, there are a few different types of services, each for a different job. Cluster IP is just for internal chatter between your apps. Node port is handy for some quick testing. But for us, we're using load balancer. Now, in a real cloud environment, this would spin up a big, expensive piece of hardware. But Docker Desktop does something really clever. It just maps this service directly to our local machine, to localhost. So how does this service know which pods to send traffic to? It uses something called a selector. It's basically a search filter,
Remember how our deployment is managing our pods? We give those pods a label. Think of it like a little name tag that says app equals Node.js app. Then we tell the service, hey, find any pods with that name tag and send them my traffic. It's a really elegant way to connect them.
And check this out. We apply the configuration and look at the result. Our service has an external IP of localhost. That's the Docker desktop magic I was talking about. What this means is we can now finally open a browser on our own computer, go to localhost 3000, and see our app running inside Kubernetes. We made it.
Being able to hit our app at localhost 3000 is awesome for development. But in the real world, you want nice, clean URLs like myapp.com, not some random IP address and port number. This is where our final piece of the puzzle, Ingress, comes into play. Think of it as the smart front door for your entire cluster.
Now, it's really important to get this straight. An ingress resource, by itself, doesn't actually do anything. It's just a piece of paper. It's a list of rules. A rule might say, if a request comes in for api.myapp.com, please send it to this specific service. But a list of rules can't enforce itself.
It needs an engine to actually do the work, and that engine is the ingress controller. This is a real application, usually something like Nginx, that's running in your cluster. Its job is to watch for those ingress rules and then reconfigure itself on the fly to route traffic exactly how the rules dictate. The rule is the what, the controller is the how.
So we create a really simple ingress rule. All it says is, hey, any traffic that comes in asking for the host nodeapp.local, I want you to route it. And where should it go? Send it to our Node.js service on port 3000. It's a simple but incredibly powerful way to map a friendly name directly to our application. And this is the final payoff. After one tiny little change on our local computer to tell it what nodeapp.local means, we can now access our application with a clean, simple, professional URL. No more IP addresses, no more port numbers. Okay, let's just take a quick step back and look at the whole picture, because we've just built a really powerful foundation. Let's see how all these pieces fit together. It all flows together beautifully. It starts with a pod, which is just running our app. Then the deployment acts as a manager, making sure our pods are always healthy and we have enough of them. The service gives those pods a single stable address inside the cluster. And finally, the ingress acts as the smart traffic cop at the front gate, directing outside users to the right service using a nice, clean hostname. You see how each piece builds on the last? Together, they create this robust, scalable, self-healing system. You've just laid down the absolute essential foundation for running pretty much any modern application on Kubernetes. The only question left is, what are you going to build and scale with it?